Question 6 on page 334 is stunning. It really is. It doesn't look like much, but trust me, it's a lot. Question 6, page 334. It says a cuboid measures 8 by 6 by 5. Yeah, I can handle that so far. And they just jump straight into the question. No hints, no nothing. Calculate angle BAC. Let me just try and draw that in. BAC is this sort of angle here that's across the bottom of this black line here, joining A and B. There it is. So let's just do it. I've got BAC is the one I've actually coloured in, and we've got to find that angle there somehow. We've got a lot to do to get there. I don't know the length of AB, I don't know the length of BC, I don't know the length of AC. So I've got a blank dotty triangle sort of slanting away from me, which makes it even harder to see. I've got to get some lengths between A and B, B, C and C and A. If I can get those lengths, then I can play with my cosine rule. So it's really easy. Look at it. I think I can work out this length just here, because look, this is a cuboid, that's a right angle, and right angles and straight sides speak of Pythagoras. So really, BC is without doubt the hypotenuse of the triangle BC and XC. So there we go. And triangle BXC, CBX, whatever, is a right angle triangle with side 6 going into the screen and a height of 5. So again, in one step I want to work out BC. Alright, so here we go. BC is going to be 5 squared plus 6 squared, and then you hit the square root button. Alright, just do that quickly. So 25 plus 36 equals root equals. So I've got 7.8102. Okay, let's leave it as it is. So I know what that is, so I'm going to try and write that on there now. Actually, I won't try and write it on there, it's difficult because it's slanted, I can't really do it. Now, so I know what BC is. I'm going to do the same with AC, because I know I have 8 across the base here, and the height is still going to be 5. So I put 5 centimeters across there. I can do exactly the same to AC, and do Pythagoras in one step. So if I put AC down here, then AC is going to be 5 squared plus 8 squared, and then you hit the square root button. Do it in one step. So 25 plus 64 equals, and now we're going to root that, and that gives me 9.433. That'll do. 9.4339. That's good enough. And that's that one. So I've got BC, I've got AC. Now I need to work out AB. Well, AB is not difficult, because if it's 8 across here, then it's also 8 across there as well. And if it's 6 across there, going from C to X, then it's going to be 6 across there as well, going from this corner, this vertex, to B at the back. So here we have, I've got a line down triangle, like half a sandwich thing, and there's a right angle triangle there, and BA or AB is the hypotenuse of the triangle AB, I don't know, R or something, just for want of a better term. So there we go. I can work out AB as follows. It's going to be 8 squared plus 6 squared. Not in that order necessarily. Could be 6 squared plus 8 squared. And then you press that square root button. So let's bring it down a little bit. So we've got 64 plus 36. Of course, that's 100. And square root of 100 is going to be exactly 10. So I will now attempt to write down these lengths. Well, this one is 10. No problem. This one's going to be 9. If it stops getting glitchy, I'll be really grateful. Right, glitch fixed. 9.4339, and this one's going to be 7.81 rather, 7.8102. I hope you can just about see that. So I'm going to play with this one, and this one. Okay, these are the 3 lengths on the dotted lengths shown there, and I've got to work out angle BAC, and that's what I highlighted earlier. There it is again. So how do you do angle BAC? Well, I want BAC, and let's just call it something. It's quite hard to put BAC at the end of a cos rule, so let's just call it I don't know, angle A. big A, shall we? Again, like that. So I need to start off by going opposite big angle A, and that's 7.8102, this one here, and squaring that. So here I go. Let's just start off carefully in black. It's really tricky, it's work down here. So I've got 7.8102 squared equals the other one squared, which is 9.4339 squared, plus the other one, of course, is 10 squared, minus two lots of that and that, 9.4339 multiplied by 10 times the cosine of BAC. But I don't want to write down BAC, I just want to call it big A in the traditional sense that big A is the angle in the corner that we want, times cosine of A. Besides, I've qualified it there by putting an A in brackets. So let's just work this all out then. We can do it in bits, or just bring this whole negative term over to the other side, which is what I usually like to do. So take all that little blob and bring that next door and subtract, and bring this little blob over and subtract on this side. So big mess, but that's what I'm going to do right now. So I've got two lots of 9.4339, I believe, yes, multiplied by 10 multiplied by the cosine of the angle we want equals 9.4339 squared plus 10 squared minus 7.8102 squared. Let's just work out all these bits and pieces. So 2 times 9.4339, of course, times 10 gives us 188.678 cos of the angle that we want, and that equals this side here. So let's just work that out. 9.4339 squared plus 10 squared is 100, and then subtract 7.8102 squared, and that gives us 127.999. Okay, so the cosine of the angle that we're after, remember the angle is BAC as shown, is going to be 127.999 all over 188.678, and let's just do that. That gives me 0.6784. That's good enough. And I've got to work up here now, so I've run out of space. So the cosine of the angle I want is 0.6784. Therefore, the angle that I want, which is BAC, is going to be shift cos of that. So shift cosine equals, I make that 47.28, 47.3 degrees. I sure hope I'm right. I've done 3 lots of Pythagoras just to get the 3 dotted lines. I've used those to implant them or substitute them into the correct position of the cosine rule formula. I've done some rearranging, I've pressed some shift cos buttons, and I've ended up with 47.3. I better stop the video there and review, just in case I've hit the wrong little button, I've made a mistake somewhere. Well, the maths is correct in terms of the procedure, but I can't guarantee I've hit the right button on my calculator for you. I'll check it in the answer book, and I will get back to you and confess all my wrongs if I've got it wrong and fix it for you. But that's a wrap for now.